Alright, so here we are at WPC 120. The stream feeds right into a bridge, you can see here, and they've actually have started to do a bunch of stream bank restoration. So they've laid down some stabilizing cloth, and they've also replanted a ton of vegetation here. Those are most of those flags. The stream itself looks pretty typical to what we've been seeing. A fair amount of gravel size to fine sediment. Definitely some algae where there's slower moving water. And there's definitely a bit of turbidity as well. It's not totally crystal clear. And this is WPC 120. Alright, so here we are at EPC 120 on the east fork of the Plum Creek, right under the 85 bridge. And you can see here there's also been quite a bit of restoration effort. That's to keep cows out, but all these flags here is revegetation. And it looks like they've put in some sort of flow regulation here with a bunch of boulders and riprap to hopefully slow the stream flow down and reduce erosion. And the same thing on this other side over here. In terms of the water, looks fairly similar to what we've been seeing. Pretty fine sedimentation, maybe a bit of gravel, maybe. Got a little bit of algae in here, a little bit of turbidity.
It looks like we've got a lot of erosion down here in this spot where they've tried to do some bank stabilization and create a little bit of a benched floodplain there, but that bench is eroding out. There's also a large spot of erosion upstream. I don't know how well you can see it. I'll try to zoom. So this is just upstream on East Plum Creek. You can see right over here, there's a lot of erosion over there. So I think those are the two sites we're going to look at for erosion here. This is at PC 120, the confluence of East and West Plum Creek. So I'm going to be taking the sample right down here. This is right after the two, well, I might actually move a little farther down just to see if we can get to a spot, maybe down in that stretch, where we can make sure that we've had some good mixing. You can see there's a lot of riprap on this section of the stream. The owner brought us down here because this is on private property, and he was telling us that they've lived here for a number of years, and at one point those trees back there, that bank was being completely scoured out by the creek. I don't know if you can see, but I'm standing on some very, very sandy soil, and there's quite a bit of sandy soil here in this low portion of the floodplain. But East Plum Creek is this one over here, and this one is West Plum Creek. The owner told us that West Plum Creek used to be the larger of the two, but more recently East Plum Creek has higher flows. So I'll just give you a little bit of a tour here. You can see the bank kind of raises up a little bit there, so I'm on kind of this low sandbar. When the owner was showing us this site, he had mentioned that the spot where I'm standing right now, if there's a really heavy rainstorm upstream of here, this entire area will be flooded all the way up to the other TA's car there, the white one. So this area it sees some pretty high flows. just based on that information from the gentleman who lives here. And you can see that in this spot where there used to be the scour, this is on the west side of the creek right after the confluence. For reference, there's a confluence. So it's maybe 50 yards away. They've had to add a bunch of this riprap and fill to try and keep those trees alive. Looking upstream on West Plum Creek, we've got a pretty steep cut down to the creek bed. And then over here, I'll try to get a little closer. Over here, there's just more of that sandy floodplain to the east of East Plum Creek. And there you'll notice a bunch of piles of riprap where they're trying to stabilize that bank because it's been cutting into the owner's property here, it sounds like for a number of years. And so he's pretty concerned about that. And he had also mentioned, he's very interested in our work, and he had also mentioned that up near their barn, which is kind of close to where you can see this like trailer, up near their barn, they found some very, very fine white sand. So down here at the creek bed, this sand is all pretty coarse, but he had said that it's pretty. There's a spot where it's really fine over that way. So a lot of erosion at this location. All right, let's go ahead and grab some sample. I'm gonna go ahead and sample right down there so that we can give these two creeks a little bit of mixing time. Okay. Alright, so we've got 3 different sample bottles here. We have one 1 liter bottle for TSS, a 300 milliliter bottle for FIB, and then I'm also going to be filling up another 1 liter bottle for everything else. So those are our metals samples, the anions, COD, DOC, alkalinity, and our probe measurements. So I'm just triple rinsing the bottle to kind of contaminate it with the sample. I try to roll it around so that the water contacts all the sides, and then I dump it a little bit downstream because when you dump it out, it disturbs the sediment on the bottom of the stream, and so that would impact our TSS measurement if we've disturbed that. Remember if I've done it 3 times. So we'll just rinse each of these 3 times, and then I like to point the bottle upstream, and then we also want to make sure that the surface water, that we aren't like capturing the water that's at the surface, because that's not necessarily going to be representative of the whole water column. So I try to submerge the mouth of the bottle completely, and that's how we're collecting samples. So we collected water at EPC 120, and we've got a bottle just like this that was collected for TSS. We also have a smaller bottle that was collected for FIB, but those ones are already in the cooler because we don't have any further processing to do for those in the field. And so we're going to pull out a syringe and take up a little bit of the sample in the syringe. I like to just grab a little bit and then pull the syringe out the rest of the way. Give it a nice swish in there to clean out the inside. And we'll just do that 3 times to make sure that the syringe is completely washed with the sample. Alright, so after we're done washing the syringe, we have 1 vial here that is for total metals. Total metals we're not going to filter, so we can just take up some of the sample, and I'm going to add about 15 mils of the sample unfiltered to the total metals vial. Now that one's ready to go, and that'll be acidified in the lab. Just waste the rest of that sample because I have more than enough here. And then take up another about 15 milliliters. And then we have these syringe filters. So I'm going to add one to the end and just give it a push to waste it, 3 pushes to clean that filter. And then we need 15 milliliters in a Falcon tube filtered. And this is for dissolved metals. Alright, so our metal samples are ready to head back to the lab where they will be acidified. And then there's a fair bit that we have to filter in the exact same way for the analysis for anions and COD and DOC. And we're going to put that in this little amber glass bottle. We've already cleaned this filter in the syringe, so we're good to go. And I'm just going to fill the bottle all the way up. And since these are only 20 ml syringes, it takes a couple times filling it. This was pretty clear water, so it's not really clogging the filter. And I'm just going to put a little bit more of the sample into this 50 milliliter Falcon tube, and we can use that for our probe measurements. And to make everything really easy when we get back to the lab, we have a bag that's been labeled for this sample site. And so we're just going to put all 3 of these that are complete into that bag. And I'm going to add this one after we take our probe measurements. This pH probe has already been calibrated. We're just going to wash it off with some DI water. And then remember to always blot when you are drying off your probes. Alright, so that one looks pretty dry. I always like to check in around the bulb. Sometimes water can get stuck in there, but it's looking pretty good. So since this has already been calibrated, I'm just going to put it right into our sample. And then click the read button on the multimeter. And it's good to kind of move it around in the sample a little bit so that it gets really good contact with the sample. Alright, so our first pH measurement was 8.54, and I'm just going to note that. I'm just going to go ahead and wash the probe, let it dry again, and submerge it in the sample. We're just taking triplicate readings. We again have 8.54. And then one last time, it seems like the pH readings are pretty stable, so that's always a good sign. Alright, our last reading is 8.52. So now we can cap this because we're done with it. Ideally, we would have been also measuring conductivity out in the field, but we're not going to do that, and I'm not going to demonstrate it for you because it's the exact same process that we just did for pH, except we would plug in a different probe. We were having some issues with our conductivity probe and our multimeters earlier today, and so we weren't able to get any good readings in the field. We'll be taking those samples back to the lab to try and get that data. Alright, so once we're done with this vial, we can go ahead and put that in our bag. And those are all of the things that are going to go into the bag. And so I'm going to go ahead and put the bag into our sample cooler so that the samples can be held on ice until we get back to the lab. So our final field measurement is going to be alkalinity. We've found that with these samples from Plum Creek, if we take about a 25 milliliter sample. That seems to be the right sample size because a 25 milliliter sample is the appropriate volume when the alkalinity range is between 40 and 160 milligrams per liter as calcium carbonate. And so I'm just gonna fill this up to the 25 milliliter mark. All right, bottom of the meniscus is a 25. So I'm gonna put that in this little beaker. And now we're done with that sample. I'm just gonna put it on ice to keep it cold. And when we use a 25 milliliter sample, we're going to want to dilute that into a total of 100 milliliters of solution. So I'm going to use my DI squirt bottle to add 75 milliliters to that. And we're good to go. So as a first step, we're going to add the phenolphthalein packet. And so far what we've seen is that there's no color change with phenolphthalein. We're just adding it as a check. So with phenolphthalein, try to swirl it a little bit. It's still very, very clear. We're going to go ahead and move on to Bromkressel green. Alright, we've got a color change. And then we're keeping our digital titrator hooks in some deionized water while we're out in the field. So I'm just going to pull one out. From what we've found, the 0.16 normal sulfuric acid is the appropriate one. So now that I've got the hook on there, I'm just going to twist this end until we see a couple drops coming out of the end of the hook. I'm just going to wipe the end of that to make sure we're not adding any extra acid. And I'm going to use this knob here to reset. So you can see we have, let's give it a stir. It's lovely, lovely green color here. And it's important to stir every so often, especially as you get closer to that head point. And now we're going to clear. I'm going to go ahead and put something white underneath it so I can see the color change a little better. Nope, not even quite clear yet. Still just kind of a light pink. Okay, maybe a little more. I don't know, it depends. I don't know, I think it's right on.
I think that looks good.
Okay. Alright, so now that we have this nice pink color, we know that we've reached the end point for Bromkressel green. Looks like we added 298 units. So I'm just gonna note that down. 298 units is a 0.4 multiplier, which you can get from a table. And we used a 25 milliliter sample and 0.16 normal acid. And that's it. That's our sample processing in the field.